Hi everyone, welcome to this section. In this section, I will give information about the main objectives and the benefits that you will get from this course. As the name of the course suggests, in this course, you will mainly focus on development of microservices. With the help of microservices, you will be able to develop and deploy your application components independently. In addition to that, you can easily scale services based on each service's own resource requirements. For example, you can scale more and create more instances of a service which requires more requests per second or throughput than the other services, so that it will be able to continue to respond and continue to be resilient. I will use Spring Boot and Spring Cloud Stack to develop our microservices. Spring Stack will help us to reduce development time by providing most of the dependencies with the help of auto configurations. While developing each service, you will be applying microservices patterns, and in each section, you will go into the details of these patterns. I want to briefly mention some of the patterns you will be using. Externalize configuration. With this pattern, you will separate and manage the configuration from the application itself. This will help you change the configuration without touching the application code, so that no compilation or build will require to enable or disable a configuration. In our examples, I will be holding the configuration on a remote GitHub repository, and for the implementation of this pattern, I will use Spring Cloud Config. API versioning. In the communication of services, there should be some predefined contracts that will allow to send and receive requests safely. But what happens when the contract changes in a microservice? In that case, you may need to apply some kind of versioning to prevent failure. And one of the most common ways to do that is using API versioning, which simply creates a new version when a breaking change occurs, and let the callers use the previous version until they are ready to upgrade to a new version. There are different options to implement versioning, such as using URL or accept header, and I will be implementing examples of both versioning with URI and versioning at resource level by using the accept header. Service discovery. While working with many microservices, you will need to register and find a service that you want to communicate. For this purpose, you will use Eroka Service Discovery Library from Netflix along with Spring Cloud. API Gateway. When you want to reach multiple services for a single request, this will require multiple requests for each service. If you hold a gateway in front of all services and let the clients communicate with this gateway, you can hide the complexity of calling multiple services from the client and use routings to call the backend services. For example, if you want to return the aggregated results to a client in a single call and you need to gather the data from multiple services, you can use a gateway to hide the complexity of calling multiple services from this client. Also, applying some solutions to microservices like client-side load balancing, circuit breaker, rate limiting, applying authentication and authorization, it is mostly better to hold a gateway in front of the services and apply the solution in the gateway before routing the call to the backend services. You will be using Spring Cloud Gateway solution, which is most up-to-date solution in current Spring ecosystem for API Gateway. Circuit breaker. What will happen when a microservice stops working or starting to respond slower than usual? In that case, the caller service would hang, or start getting unexpected errors or delays. To prevent this, we can check the health of each service and apply a failover scenario for each request. Circuit breaker comes to the picture at that point, where you return either a cached or default result to the caller instead of letting it to hang or getting unexpected errors. Setting proper timeouts and applying a retry policy is also necessary at that point. You will be using Resilience4G library along with Spring Cloud Gateway for implementation of circuit breaker in our examples in this course. Rate limiting. You may have heard about DDoS attacks, where an attacker sends huge amount of requests to a system to make it unavailable for normal users. These attacks mostly target the APIs or services, where there is a heavy work going on. If you find a way to detect this behavior, you can then prevent the request of this source before reaching to the service itself. Rate limiting helps here. You apply a limit for a client request, for example 10 requests per second at maximum. And you do this at the gateway level. Any request that goes beyond these limits will be blocked at gateway level instead of routing to the backend service. You will use Redis, which is an in-memory key value store, for applying rate limiting at our gateway, again along with Spring Cloud Gateway solution. Event sourcing. Communication between services either can be direct calls like a REST call or can rely on events, such as a service creates an event in an event store, while another service subscribes to the event store and consumes the events asynchronously. When you choose to use events, you need to keep the events in a place, and you will be using Kafka in our examples for that purpose in this course. CQRS, Command Query Responsibility Segregation. This pattern tells us that command part, which changes the data, should be different than the query part, which just reads the data in a system. This is important because we can then design the command and query parts differently, such that using different models or even using different data stores, which are better for specific reasons. For example, if you use Elasticsearch for query part of your system, which we will do in our examples, it will come with a lot of benefits, as Elasticsearch is designed as a query engine. Applying this pattern will mostly result in eventual consistency, where the read store will be updated asynchronously and possibly with a small delay. In most of the systems, this delay won't cause a problem. Authentication and authorization with OAuth 2 and OpenID Connect protocols. When using multiple services, authenticating each request and applying authorization for each resource is important. Using the OAuth 2 protocol is kind of a de facto standard in microservices environments, where using GWT as the token type is also very common. In this course, you will be using OAuth 2 protocol with GWT token type with the help of new Spring OAuth 2 resource server and client dependencies, along with the open source Keycloak authorization server. You will also be adding OpenID Connect protocol to distinguish authentication and authorization, where OAuth is originally designed for authorization, and OpenID Connect protocol came to the picture later to fill the authentication gap in OAuth protocol. Monitoring. It is important to monitor the metrics of all microservices, such as memory usage, request per second, and response time. With the help of Spring Boot Actuator, Prometheus, and Micrometer, you will extract the metrics that you want to get. and you will show them in a nice dashboard on Grafana in this course. Distributed tracing, log aggregation, and visualization. As I mentioned previously, when working with microservices, the communication between services can either be through REST interfaces or by using some event source and event-driven architecture. You will actually be using both approaches to communicate between our microservices in this course. In any case, tracing a message and determining the behavior of the application or finding an issue with a specific message is not always easy in a microservices architecture, because there is no direct relation between the separate services. In this case, you can apply an external request ID to follow a message through all the way between the microservices. You will implement distributed tracing first with SLF4J MDC, and then replace this solution with Spring Cloud Sleuth and Zipkin to better monitor and trace your application. And with the tons of logs that are coming from all services, it will become more and more difficult to find an issue or follow a message or understand the behavior of the whole application. You can use ELK stack to centralize log store and visualize it to easily find what you are looking for. You will be using Logstash and Kibana for that purpose, of course along with Elasticsearch, so you will have a complete ELK stack in this course. Kafka. We will put Kafka in our architecture as the event store and develop event-driven microservices with the help of it. Of course, you will first go into the details of Kafka, such as understanding how a Kafka cluster works, the purpose of brokers, topics and partitions, understanding how partitions help to scale naturally, and finally going into the details of producers and consumers using the Spring Kafka dependency. Elasticsearch. You will be using Elasticsearch to implement the query part and also to aggregate the logs from various microservices. And again, you will first learn the basics of Index API and Query API of Elasticsearch, with some example query requests sending them to a local Elasticsearch cluster. You will also be learning Spring Elasticsearch dependency to easily query Elasticsearch. Containerization with Docker. As you will see throughout the course, containerization is a perfect match for microservices. And you will be running everything inside Docker locally in your machine, so that you can easily ship your application to any cloud vendor in future. Reactive development. There will also be a reactive development section in this course, where you will be using Spring Elastic Reactive Library, along with Spring Boot Reactive REST Client, which is called Web Client, and with the Reactive Timeleaf. Please note that you will be able to download the source codes in each lecture separately, and for any problems related to source codes and running the project, or related with the theory of the concepts, you can ask your questions in the QA section. Please note that I have updated the captions for the videos, so you may also follow the course using subtitles. Alright, in the next lecture, let's see the overview of the application that you will be developing in this course. I will see you in the next lecture.